Welcome to Lake Cumberland Amateur Radio Association. You can find us at LCARA.net, on Facebook, on YouTube, and on Instagram. If you're enjoying the videos we're producing here at LCARA, please help our club out by hitting that subscribe button. Also, give us some feedback on our videos. Click the like button, share with anybody who may find it interesting, and be sure and hit the bell icon to make sure you get notified of the next video release.
I'm KY4 BDP Brian for the Lake Cumberland Amateur Radio Association, and today I'm out here on the deck with nature singing along. You may hear some cicadas and some of the birds here on the compound. One of the nice things about living in a rural area is nature, and it also makes for a great environment for antennas, especially dipole antennas. Now, you've seen me utilize link dipoles in the past. The soda beams for going on the road, very lightweight, just link the little pins or the alligator clips for the length that you need, 80 through 10 meters. I've also built a link dipole utilizing those Anderson power pole design that we put out a couple of videos for as well. But the downside to a link dipole is that if I want to change bands, I got to take it back down, adjust those alligator clips or the Anderson power poles to get the length of wire that I need. And it's an equal length of wire on both sides. But the great thing is it's flexible, it's easy to deploy, and it's relatively lightweight. Well, today I'm going to experiment with a different type of dipole antenna known as an off-center fed dipole. Now, this is from Palomar Engineers. Probably not a company that you really associate with antennas, mainly for chokes and ferrites, things that you can do to reduce RFI and EMI in your shack, but mainly RFI in this particular case. And they have great chokes and the balins and the ferrites and so forth, and they're quality pieces of equipment. And I got to looking at the off-center fed dipoles, and many of them are quite expensive. And when you think about it, two unequal lengths of wire with a baling in the middle and a feed point, how expensive do they need to be? Palomar Engineers actually sells two models. This one, the PAL OCF 8010, and I think a higher powered one, or actually fewer bands. But regardless, those are the two off-center fed that they do. And they also do something unique typically for these off-center fed. Many of the off-center fed dipoles that are out there are 33% length on one end and 67% length on the other. This is actually measured a little bit differently still, so that some of the other bands that you might like to attempt, like 12, 15, 17, and 30, are included. So they use a 29-71 percentage on each end. Now you might wonder, why off-center fed? Why not just use equal lengths? You could, but the off-center fed dipoles actually have a nice radiating pattern if you go look at some of the charts. So in the next segment, we're going to take a look at this antenna. Let's take a look at how Palomar Engineers puts together an antenna. I think you're going to be impressed with the quality, and then we're going to actually take a look at where we're going to put it on the compound here and then run through those tests. SWR on multiple bands, as well as try to make some contacts earlier in the day and later in the day when some of the bands become more operational. So I'll see you in the next segment. Welcome back. So I've got the Palomar Engineers PAL-OCF-8010 out of the bag, and we're going to have a quick go around here. On the bottom we have our SO239 for connectivity to a lot of different feeds that I have around the house. I don't know that you can get this in a different connector. You probably could take this one off, desolder it, and solder on the one that you like, but it does come with that, which works for a lot of cable that's out there with UHF ends. We have the stainless steel hardware for the ears, for the connections of the short and long lengths of wire. We have a top stainless steel option here, or eye hook, for attaching it to a tree or a mast, for instance. They do recommend you get this attached about 30 feet up in the air, and the lengths of wire at the ends 15 feet up in the air or more. We also have the two lengths of wire right here. So you've got a 39-foot length and a 94-foot length with insulators on the end so that you can attach them easily to something on those ends. I'm going to be using fence top rail to achieve that I use for my other link dipole projects. But what really kind of dominates the screen here is the actual enclosure. One of the things that Palomar Engineers does, because they're experts in reducing RFI coming into your shack, is they build a choke into this enclosure. So not only does it have the balun, because you're running unequal lengths of wire, but it also has a choke built in. This has a 4-to-1 balun built in, and it also has a 1-to-1 choke. And it is good from a frequency standpoint from 1.8 to 61 megahertz. So it's going to be really wide banded. In fact, you can go from 80 all the way down to 10, and a lot of the bands in between that you as a general, you have access to, and certainly as an extra as well. So in the next segment, we're going to take off the nylon ties. We're going to start unrolling this and see how we're going to attach it to the top rails. The top rails that I'm using will get it about 20 feet off the ground on the ends, and the mast that I'm going to show you is going to definitely get it about 30 feet off the ground. So see you back here or down there at the next segment. All right, folks, so now you can see I've got it kind of rolled out here. Got the choke balun here just positioned, ready to go up on a mast. I've run the short length of wire out this way. Be careful when you run the wire out, because it does take a little bit of methodology and taking some care to make sure you don't get any kinks. And so that's going to go to a top rail right over at the fence row. And then the long length of wire is going to go out this way. And it's actually going to attach to the middle pine tree that you see in the viewfinder there, and it's the deepest one as well. There's one to the right with the dead branch there, and then one to the left. It's the one in the middle. And again, be really careful when you roll this out. You don't want to get any kinks. Occasionally wire like this won't quite unroll the way you'll need it, which means you got to futz with it a little bit. Futz is a technical term we use here in Kentucky. And but once you get all of that wire out, make sure that it's not coiled. Try to straighten it out as best as you can. Now we're going to attach the feed point here, the little box, to a mast. Now I've been utilizing a fiberglass mast, and it's been working really, really well. Love it. In fact, I may utilize that mast for this a little bit later, but for today and for this demonstration, I'm going to introduce another mast that I have procured, and this is a carbon fiber mast from Gigaparts, and it is extremely strong. It's lightweight and extremely strong. Can't hardly break these things, and this is what I'm going to use for traveling primarily, but I'm going to introduce it today and know that it will have no problem holding the choke balun piece here, which is a little bit weighty. Keep in mind, Palomar Engineers recommends that this box, the center point or the off-center fed, be 30 plus feet in the air, so the carbon fiber mast will get me that kind of height. So when I bring you back in the next segment, we'll have all of this set up, both ends connected and off the ground at least 15 feet, and the center will be at least 30 feet up in the air, and then we'll begin checking our SWR on different bands for those generals and extras. I'll be back in the next segment. Well, it took a little while and a few guy lines, but I got it up there. So we've got it mounted up at the top as far as the choke and the balun, and then if we follow the wires down, we are connected to top rail over there by the fence. So I'll just walk over there quickly. So you can see the top rail going up in the trees, and I made sure we're not touching any branches and trimmed a couple of branches. Then back over here, we have the mast again, so you can see it. And then we go over to the middle pine tree for the long extension. So we've got it installed, folks. Hot day, hot muggy day in Kentucky, but it's up. Now's the chance to give it a try, and let's see if we can make some contacts. Also, check that SWR on the different bands that Palomar Engineers says we can get away with. See you in the next segment. All right, folks, we are back indoors, and man, it is hot outside. Over 90 degrees here in southeastern Kentucky. High humidity. That's what makes it so bad. It's a black flag day, as we used to say in the Marine Corps, so you really don't want to do a whole lot outdoors. So I started early in the morning, and with the guying of the mast and so forth, man, by the time I got done, it was 11 or 12 o'clock. It was already starting to get too warm. I'm glad I'm more or less done. Let's check some SWRs, shall we? Now, this antenna is marketed for 80 meters all the way down through 10 meters. One of the other things that they mention is that a lot of these off-center fed dipoles do not work well for some of the other bands in between 20 and 10, 17, 15, 12, for instance. This antenna, since it's shifted to 29% on the short end and 71% on the long end, is supposed to make up for some of that so that the other bands are usable. So we're going to check from 160 all the way down to 6. It's not marketed for 160 and it's not marketed for 6, but we're going to check some of those bands anyway, just as a baseline or as a check, if you will. And I've already set it up here on 160 meters, and we're at 1.8. Now, 160 meters is 1.8 through 2, and so in this particular case, we can actually start at about 1860, which is actually where I'm set. I've already got it ready for the SWR check, and then we'll go from there. So let's hit the microphone and see what happens at 160 meters. Oh, that's going to hurt. Yeah, that's no bueno. That's not going to work. I don't even think that'll tune. Let's see what happens. Negative. Not even going to tune. So was it marketed for 160? Not going to do 160. So, all right, we'll move on. Let's move to 80 meters. And what I've done is I've set it at 3,800 roughly. Actually, we want to come down a little bit here. Let's come down to 3,600. Let's get it out of that. Now remember, the band starts at 35, and if you're a digital hound, this antenna is supposed to work really well for you. But one of the biggest compromises with vertical antennas typically is that they don't cover much of the band. They have a very narrow slice. My AV640 from High Gain doesn't even cover 80. You can get that option, but the reason I didn't is that it would have been such a narrow slice of 80 meters. But dipoles, horizontal dipoles, typically can make up for a lot of that. So let's see. Let's turn on the SWR. Let's see what we get. Oh, nice. Folks, I haven't touched anything. I just put up the antenna. I haven't done anything. So you'll notice as we go over towards 3540 on the left, it's, you know, just above 1.5. Not bad at all. And it's approaching 2 over at about 3660. That's really usable. Now, I'm not on the digital side much these days at all. I'm mostly going to be 36 and to the right. So let's move it to 37. So I'll be 36 and higher. So let's see what happens here. We know it's going up, but it would still be usable. Oh, yeah. Now, a lot of radios will clean up an SWR less than 3, and we're definitely less than 3. And I'm really chuffed. That's nice. My vertical doesn't cover 80. This can definitely cover the 80 meter band for me. With a little bit of tuning, I can clean that up even a little bit more, and maybe futzing around with the antenna a little bit. Maybe get the ends a little higher or the mast up a smidge higher. Who knows? But that's usable. All right, let's try one more just for fun. Let's go up to 38. And try it one more time. Oh, yeah. So, you know, we're approaching 3, of course, right after 38. It looks like, I don't know, probably about 3830, 3840, somewhere in that ballpark. But still very usable at that point. And if I use my tuner, I can probably clean up a lot of that right off the bat. Let's give it a go. Try it one more time. Yeah, look at that. That is pretty darn good right there. And that gets us all the way to 3860. And if I move a little further, let's just go to 3860. Let's run the tuner one more time. Yeah, absolutely. So with a little tuner help, no problem. Now keep in mind, I got a pretty wide swath. Let's turn off the tuner. Let's go back to 37. Starting at 36 to 37, we're in pretty good shape without the tuner already. But again, it'll clean up some of this. Just over 2 at about 37 and going to the right. But again, the tuner will clean that up nicely. So I'm happy with that. Really happy with that. Let's move to the next band. Alrighty, so now when you move to 40 meters here, this is going to be 7 through 7.3. And again, a portion of that band I don't use because it's the digital portion of the band. So about 71, what do we got there? 7125, 7.125 is going to be where I can start as an extra and as a general. So let's start at 7175 and let's see what we get. Wow, that is really usable, and we're probably in the trough here of the chart, and that's nice. That takes us all the way out to all the way down to 7175, and all the way up to 7275. That's an 11 bar. Let's go 13. And really, I should be using RTTY here. Let's go back to, or let's go to RTTY and try it one more time. Try to do these things correctly based on what I've been taught. There we go. Yeah, so we're looking at 7165 all the way to 7285. And remember, the band is going to stop at 7.3. So we're well below 3 and just tipping 2 across that portion of the band. That's not bad at all. And again, the tuner will clean that up. So another usable band right out of the gate. Let's move up to 10. Now, some of you that are new, you're probably saying 10 megahertz? What band is that? Well, that's the 30 meter band. It is all digital. 200 watts max on this band as well. If you get your ARRL, US Amateur Radio Bands chart, it's all red. There's nothing there for voice. So we definitely don't want to use upper sideband. We'll go back to RTTY. And let's try this. I'm going to do 13, but it's a very narrow band, 10.100 through 10.150. And we're at 10.135 just to kind of capture it. No tuner. Going to turn it on. Not looking good. Now, if you look at the documentation for this antenna, it's not marketed for 30. And let's see if we could tune it at all. Maybe it's right at 3. No. Not going to happen. So 30 is not in the game for us. If I wanted to use this antenna for digital, no bueno either. All right. We weren't thinking it would work on 30, but we tried it. On we go. 14. Now 14 is a major band for a lot of people. And 14 is going to be your 20 meter band. And during the day, hey, this is a band. If you look at the top, the wave waterfall is showing some traffic already. And this is 14 megahertz up to 14,350. So I want to, again, kind of place it in the middle for the usable portion I'm going to use mostly, but that starts at about 14,150. So let's come down to 14,150. Again, we'll use a 13 bar. And that'll allow us to look to the left at 14,200, which is getting down there in the digital portion, all the way up to 14,321, which is pretty close to the top end. Let's give it a go. Well, that's not great. What if it's just kind of close to 3? It did tune. Huh. Is that correct? I wonder. Let's take out the tuner again. Well, you might be able to see towards the right-hand side here. My fingers are in the way, aren't they? Right here towards the right-hand side, it's just starting to drop below 3. So we're right at the threshold of this radio. And again, let's tune it one more time. Didn't take long. That's a win. That's a win. So out of the box, it's not great on 20 meters based on how I've got it mounted and so forth. But the radio will tune it to make it usable, make my radio happy. That's a win. So 20 meters is now in the win column. Let's take a break, and when we come back, we'll do a few of the other bands. Alrighty, we're back. So I just did 14 megahertz 20 meter band. I didn't go up to 350, but if you remember, it was starting to come down on the far right-hand side, so I didn't test that, but I'm almost certain that'll be fine. What I've now moved on to is 18 megahertz. And you'll notice it's 18, and there's a lot of you, again, if you're new, you're probably saying, what's 18? What's around here? This is actually called the 17 meter band. And if you look at your ARRR ARRL chart. I'll get it out in a minute. There's a portion of it that's for digital, and there is a portion for voice from 18.110 to 18.168. So it's not very wide, but it is there. So a lot of these off-center fed dipoles can't do 17. So because of the way they're manufactured, they just don't. So let's see if this one is manufactured maybe just a little better and will get us 17 meters. That is a win. That is 1.0. In fact, let's switch it back to ready one more time. I keep forgetting. That's a work. Now let's, I like to go 13 just for fun, just to make it consistent. Ah, nice. You can see it starting there on the left nicely. This is the best band we've looked at so far. A band that a lot of off-center fed dipoles won't even do, but this one will. So we're in great shape for 17 meters if we want to give it a go. Sometimes you're looking to get contacts on different bands, some of the bands that maybe aren't as utilized, and it's difficult to get contacts in some of those other bands, especially with a low sunspot cycle. 17 is in our wheelhouse. Let's move on. All right, we moved to 21 megahertz. This is the 15-meter band. At times, this can be really busy. I have made some contacts on 15 all the way to California with other antennas. This one's from 21 megahertz up to 21,450. So what I've done is I've kind of placed it in the middle here. You can see it'll be about 21,265. Yeah, 21,265. Up to 21,385. So pretty close to the usable portion that I'm going to be on. Let's give it a go. Oops, let me turn that off. Let's do it right. It's coming down even. So you can see the portion that I'm going to use for voice, which is about 21,200, is definitely in the wheelhouse here. And as we move to the right, it's coming down even further. So I'm really happy with that. That's really nice. If I come down to 21,200 itself, that will include the digital portion and portion of the voice. Let's see what we get. Yeah, it's pretty much what we thought it would be. It's usable. It's coming down. It's not as low as we'd love to see, but again, one piece of wire is doing this, not a link dipole that you can tune to the nth degree. It's doing nicely. The radio will clean this up, and then if I go to the usable portion of the band as we did a moment ago, which we can go all the way up to 450. Let's go to 350. Run it one more time. This will get us close. Yeah, it just keeps coming on down. So it's only going to be better between the middle spot and towards the other end, the right-hand end. We're in great shape. One more band that many off-center fed dipoles don't do well on. This one is doing just fine. So mark it down. Another band that we can work with. All right, moving up to 24 megahertz. This is from 24,890 to 24,990. So really, you can come all the way down as far as where you want to start this. We'll put it at 930, just kind of in the middle. Huh. I think we're seeing something similar. One more time. We're technically not at the very top at 3. We're actually below 3. This is going to be usable again. Yet another band, 12 meters, that we can utilize. And again, this will tune just fine. And we're bang on. Very nice. So I don't know how we can get much better than that with a little help from the radio, but that's great. So far, every band but 160 and 30 have been usable. Maybe with a little help with the radio at times, other times just fine. Let's try 28. A lot of you are going to recognize 28 here. 28's your 10 meter band, and 10 meters at some times is just off the charts amazing. In a low sunspot cycle, sometimes it's not the greatest, but 10 meters is supposed to be the low end for this particular antenna. This is 28 megahertz all the way up to 29,700. I've put it at about 28,350. In fact, let's push it down just a little bit. Let's do 28,175. That'll be a portion of the digital, and I'll take that. Yeah, that'll be a portion of the digital, and then we'll see how it's going to do on voice. Oh yeah, we're in great shape. We're a little above 2, but again, it's cleanable, and it's trending in the right direction. So for the voice portion of the band, it's only going to get better. So now we can push it up to, let's say, 28,350. Now, 28,350 has some significance for Lake Cumberland Amateur Radio Association because our 10 meter net is on 28,350, and I have a hard time getting into net control sometimes with the different radios that I have, the antennas. If I use my vertical antenna, it's really hard for net control to hear me because he's horizontally polarized, and I've heard somewhere between 20 dB loss between vertical and horizontal that close together. So it's tough, but now I'm going to be mostly horizontal. So I'm curious now. Oh, it's not 1, but who's expecting 1? I'm not. We're below 1, 2. We're below 2 at 28,350, which is very usable. This is going to make my net control fella very happy. KK4JPX typically runs the 10 meter net. I bet coming next Thursday he's going to be able to hear me just fine. Now remember, this goes all the way up to 29.7. Let's just go up to 29 for fun because it is trending nicely, but it probably won't trend that way forever. I don't know. 28,900 is looking pretty darn good. Actually, that's too high. My apologies. Let's go back down. No, I had it right. 28.9 is fine. And we're really low there. It's 29.7 at the very end. Let's just go to 29.2 and see what happens. Remember, these dipoles give you a wider swath of the band. It's 1. And I should be using RIDI. It's amazing on that end of the band. Now, a lot of folks are not using 10 meters all the way over there. But isn't it nice? It looks good on the far left, and it's looking even better on the far right. No tuning required. Highly resonant on 10 meters. Alrighty, one more band to check, folks. I know this is going to be for a long video, but you guys have been asking for more SWR measurements on these antennas. Let's switch to 6 meters. One of the great things about this radio is it'll also do 6 meters. And we actually have a repeater at our club on 6 meters at 53 to 70. Well, this band starts at 50 megahertz, all the way up to 54 megahertz, extremely wide. I wonder how well it's going to do towards the bottom in the data portion. Well, technically, you can use the entire band for data or voice. So let's see. We're down at the bottom of the band. And it was at about a little under 2, and it's trending nice. It's starting to trend even better. Now, let's go to 51. We're going to skip some here. Still right down there at about probably 1.8, 1.9. Now I'm going to go up to the repeater. 270. Using USB again, but we'll work with that. Around 2. Around 2 or maybe just slightly less. This is extremely usable, and bonus, they don't even market this for 6 meters, and yet it's doing just fine. I'm not sure why they don't market this for 6 meters. My radio is happy with it. Now, I haven't tried to make a contact or anything, but from an SWR standpoint, as far as danger to your radio, it won't be. And again, with a little tuning, I could just clean that up if necessary. usually around 2. You want to try to clean it up a little bit. So very happy with that. So now we'll move on to the next segment, folks. Thanks for sticking around for the different bands, because a lot of people want to know how many bands you can use with some of these antennas. We've seen it from 80, 40, not 30, 20, 17, 15, 12, 10, and 6. And it's not even published for 6, but it's doing just fine on 6. I don't think you're getting a little value add with this antenna, no doubt about it. Great antenna. Let's try to make some contacts, and I'll see you in the next segment. Alrighty, we're going to try our friends over on Parks on the Air. Remember, if you're testing out a radio or an antenna and you want some frequencies that you know people are going to be on, and you can get a contact number 1, that's in your favor, and you can see if you can reach out with your antenna and radio setup, triple bonus. So that's what we're going to try here. We're going to try a couple of these Parks on the Air and see if we can't pick one up. There are thunderstorms north and to the southeast of me, so it's going to make it tough on some of the bands, but we're going to give it our best shot. Here we're on 40 meters. Let's see what we can do. Now, one other thing that I'll mention here, let me turn down the noise, is I'm approximately set up where the antenna is pointing, the wire's actually pointing northwest, north by northwest. So it is mainly going to pick up and be able to reach stations that are to my west, southwest, and to my southeast, or northeast, I should say. So we shall see what types of stations I'll be able to pull in today.
Calling CQ20 in my circle.
This is Kilo Yankee 4, Bravo Delta Papa. Go ahead, CQ20.
I think you're calling me. Is it Kilo Yankee 4 Delta Bravo Papa? Is that correct? Yeah, go ahead.
Negative. Kilo Yankee 4, Bravo Delta Papa.
Put you in my log here and see who I'm talking to. The name is Don, and we're in the state of North Dakota. We're in North Dakota. So, please help me out. I didn't bring up anything in my electronic log, so I must have done something wrong here. I'll give you a signal report there on that next go-around. So, back to you. Delta Bravo Papa, you said. Whiskey Tango 0 Sierra.
Right, the band is going in and out, Don, but it's Kilo Yankee 4, Bravo Delta Papa. Bravo Delta Papa. My name is Brian.
Okay, Brian. There we go. Now it'll come up. I know it will. Now if it happens, it must get a little dyslexic here. And we'll see how it happens here now when I put it in the log. It should be okay, I'm hoping. Kilo Yankee 4, Bravo Delta Papa.
Kilo Yankee 4, Bravo Delta Papa.
The Kilo Yankee 4 Bravo station again.
Kilo Yankee 4, Bravo Delta Papa.
Kilo Yankee 4 Bravo Delta Papa.
Come again? QSL, QSL, I've got you. You're about a 5-3 into southeastern Kentucky.
Okay, Kilo Yankee 4 Bravo Delta Papa 5-3 Kentucky.
QSL, thanks for the activation.
Thank you, 7-3. QRZ Parks on the Air, November 8th. Whiskey Quebec 9 Foxtrot.
Kilo Yankee 4, Bravo, Delta Papa.
Kilo Yankee 4, Bravo, Delta Papa. 5353 to the
QSL, Roger, you're about a 5-3 into southeastern Kentucky.
Thank you for the 5-3 southeastern Kentucky. Signal sounds good, it's just a little weak. Thanks for the contact today, though.
Roger, Roger, in 73s, and thanks for the activation.
73, Kilo Red, whiskey. 73, Kilo Red.
Kilo Yankee 4, Bravo, Delta Papa.
Kilo Yankee 4, Bravo, Delta Papa. This is 4,
QSL, you're a 5-3 fading to a 4-4 at times.
All of a sudden get a lot of fading. You were very strong and then just dropped out completely, over.
Roger, Roger, yeah, a lot of fade. You were about a 5-3 fading a little bit into southeastern Kentucky.
Understand 5-3 Kentucky, 5-3 Kentucky. Thank you very much for supporting the program. 73.
73, and have a great activation.
Kilo Yankee 4, Bravo, Delta Papa.
Roger, Roger, you're about a 5-3 into southeastern Kentucky.
All right, Brian, I got the 5-3. Thank you for coming to the call. I appreciate it. Hope you've had a good week, and I hope you have a good week.
Roger, Roger, thanks for the activation. Have a wonderful day.
Thanks for being a part of the fun today. This is Kilo X-Ray 4, Bravo, India.
Alrighty, what did we learn today about the Palomar Engineers PAL-OCF-8010 off-center fed dipole antenna? It's a good antenna. This antenna with that slightly different offset than what you'll see on a lot of other off-center fed dipoles, 2971, seems to really work nicely. How many bands? We had 80, we had 40, we had 20, we had 17, we had 12, we had 10, we had 6. That's the bonus one right there. It's not even on the charts, but it actually will do well on 6, at least in my implementation. I think that's wonderful. One antenna to rule them all when it comes to almost all of the HF bands, not 160 and not 30. So I recommend this antenna highly. Get it up based on the instructions. They want it at least 30 feet in the center, and they want those ends at least 15 feet off the ground. Mine are at 20, and due to the slopage, about 25, 30 feet off the ground. That gives me fairly horizontal orientation. Should work well for the Thurdday 10-meter net that we have here at LCARA, and I'm looking forward to Thurdday coming up. You saw some of those POTA contacts, 7 megahertz, 14 megahertz. I had another one sprinkled in there somewhere. I had a CQ that I brought in as well. But POTA is a great way to, again, test an antenna. You're going to know where people are, and you can get signal reports. A lot of that's going to be based on the conditions of the day, but at least you get some immediate feedback, and you're making contacts that go into a log if you're into that sort of thing. I like this antenna a lot. I'm really looking forward to keeping it up and utilizing it as my reference antenna for the base station here at the compound. If you enjoyed this video, put those comments down below. Let us know what you liked about this antenna, and let us know other antennas that maybe you have seen or have worked with, and let us know what your feedback is for off-center fed dipoles. I'm going to like not having to go out there and connect the lengths. It's one basic wire to make it happen, and it's going to be a lot of fun to utilize horizontally. For the Lake Cumberland Amateur Radio Association, I'm Brian, and I hope you enjoyed the video 73s.